This is a key to topic 11, part D worksheet, and you're still working on solving systems, but you want to determine also whether in each of these whether the system is consistent, dependent, independent, or um, inconsistent. All right, so you have these that you got to determine as well. So let's look at number one. So number one, we have this system. We have 3x plus y equal 2, and we have y equal 2x plus 7. And you want to do this by substitution. So make sure you read the direction. The direction says substitution. So remember substitution, basically you're going to pick one of the equations and you're going to solve for one of the variables. And notice that this one's already easy for you because the variable y in the second equation is already by itself. So you're going to take, so basically you're going to substitute um, y equal 2x plus 7, so this expression here, into the other equation in place of y. So then I get 3x plus, and then this is your y now, so 2x plus 7 equal 2. And then you just solve this linear equation. And so when I solve this linear equation, I get 3x plus 2x is 5x. I get 5x plus 7 equal 2. Subtracting 7 from both sides, I get 5x equal a negative 5. Divide both sides by 5. I get x to be a negative 1. So in terms of my solution, in terms of the solution, and then notice before I go on, in past worksheets, you were told to write the solution as an ordered pair. It didn't say that here. So if some of you want to say x is negative 1, that's fine. Okay, did not say rise in ordered pair. But to find the y value, you got to find y now. To find the y value, you go back to one of these equations, and in place of x, you substitute negative 1. Let's go back to this one because y is already by itself. So we're going to get y equal 2 times negative 1 plus 7. So that's negative 2 plus 7, which is negative 5. All right, and so there's your solution. Now remember, so in our lesson, we learned what it means for a system to be consistent, for a system to be inconsistent, for a system to be dependent or independent. Okay, so if a system has at least one solution, one or more, then it's consistent. So this system is consistent. This system is consistent. Okay, and since it's a finite, since it's not an infinite set of solutions, since it's finite, there's only one solution, then it's also independent. So consistent and independent. All right, so the choice for that one would have been, let's see, which one? That would have been B. So consistent and independent. So consistent means at least one solution. It does. It has one. Independent because it's a finite number of solutions. You only have one solution, so independent. Okay, so those equations are independent of each other. All right, number 2, we have 5x plus 7y equal 9, and then 10x plus 14y equal 18. And you want to do this by elimination. So 2 and 3 are going to be by elimination. So remember, with elimination and addition, at some point when you add these two equations, you want one of the variables to disappear. So it doesn't matter whether you want to eliminate the x's or the y's first. Let's just deal with the x's. So if I look at 5 and 10, the least common multiple of 5 and 10 is 10. So this is already at 10, so what I got to do is multiply this by 2. But I got to make sure that those are opposites. So one's positive, I got to make this negative. So let's multiply by negative 2. So here's what you're going to do. You're going to take your first equation, just like this, and you multiply by negative 2. Both sides. What you do to one side, you do to the other. So 9 has to be multiplied by negative 2 as well. And then leave the second equation as it is. Okay? Now, this becomes, let's go ahead and distribute. So then I get this system now. So it's negative 10x. A negative 2 times 7y is a negative 14y equal 9 times a negative 2 is a negative 18. The second equation is 10x plus 14y equal 18. Now we're going to add. When I add, notice that all these variables disappear. So I get 0 equal and negative 18 and 18 is 0. That's a true statement. So notice the variables disappeared, right? There are no variables left like there was here. So when you did this, you had a variable. Here you don't. but the statement is true. That's a true statement. This is true. 0 does equal 0. So what that means is that you have an infinite number of solutions. Infinite number of solutions. But there's a certain way that in this course you want to write your solutions. So you're going to say this. So since it's an infinite number of solutions, the ordered pairs will either have this form or this form. Doesn't matter which one it is. So all you do is say this. So your solution, you're going to say the set of xy coordinates, xy, such that, and just write one of these equations from the original problem, such that 5x plus 7y equal 9. Or you could have said this, or you could have said the set of xy's such that 10x plus 14y equal 18. Okay? Either one of those would have been fine. Now, in terms of this part here, so remember we have at least one solution. There's an infinite, so it's consistent. Inconsistent means there's no solution. Inconsistent means no solution. There is a solution. There's an infinite number. That was a true statement. So the system is consistent. System is consistent. And since infinite means not finite, remember finite is where your equations are independent of each other. If it's infinite, if you have an infinite number of solutions, that means that those equations are dependent upon each other. So this is dependent. Okay, dependent. Dependent. Okay? All right, let's go to number 3. Number 3, you have this system, 5x minus, that's a 5, 5x minus 6y equals 7, and then 10x minus 12y equal 21. So again, let's go ahead and this time, let's get rid of the y's this time. Let's see what happens. So if I see how this is 12 and this is 6, so these come a multiple of 6 and 12 is 12. So that means I got to multiply this by 2. But I need one to be negative, one to be positive. So let's multiply this by negative 2. So then I'm going to say negative 2 times the first equation listed. 7 times negative 2 as well, right? And then I'm going to rewrite the second equation. All right, get rid of the parentheses. This becomes negative 10x. Negative 2 times 6y is a positive 12y equal negative 14. And then 10x minus 12y equal 21. Now, the interesting thing about this is when I add these now, this is 0, this is 0, right? Equal. But on this side, negative 14 and 21 is 7. Well, notice the variables disappeared. So when the variables disappear, that means either you're going to get no solution or you're going to get an infinite number of solutions. In this case, that's a false statement. So this is a false statement. So that means you have no solution. So in the solution, you're going to say solution blank, you're going to say no solution. Okay? So since there's no solution, you're going to say inconsistent. Inconsistent. So the system is inconsistent. All right. And so that is the key. That is the key to topic 11, part D.